But the first thing I want to do is give an example of a learning target 4 problem, because we have roughly 28% of us at a proficient level, which I think we all know is clearly is not enough. So let's say I have 2 over 5, and I need to simplify. You will have a problem just like this on the test, okay? And this is learning target 4, simplifying radical expressions. So if I need to simplify this, I cannot have a radical in the bottom of my fraction. So what do I have to do for this particular one? The conjugate. And the conjugate of 5 minus the square root of 3 or 2 is what? I have to multiply by 5 plus the square root of 2 over 5 plus the square root of 2. Okay. Hopefully here in a second, we're going to find out exactly why in a second. Okay. As long as you know that the conjugate of 5 minus the square root of 2 is 5 plus the square root of 2. And this is what I need to multiply by. 5 plus the square root of 2 over 5 plus the square root of 2, because this is technically the number 1. Okay, the reason why we multiply this is because across the top, it's pretty easy to multiply. Just distributive property that we'll do here in a second. But on the bottom, the reason why we multiply by the conjugate is because my square root symbols will go away. And you cannot root in the bottom of a fraction and it be considered simplified. Let's see why. Because you can box method this. My guess is you would FOIL method this because that's the method you choose to do. I'm going to multiply 5 plus the square root of 2 times 5 minus the square root of 2. And then I'm going to go 5 times 5. 5 times the positive square root of 2 is positive 5 square roots of 2. 5 times negative square root of 2 is negative 5 square roots of 2. And then negative square root of 2 times positive square root of 2. It is negative 2. But this is why, because negative square root of 2 times positive square root of 2. I can multiply these and put them together to say this is the negative square root of 4. Square root of 4 is 2, but we want the negative version, so it's negative 2. So again, why did we multiply by the conjugate? Because if I add all these together, these are opposites of each other and cancel out. So what am I left with on the bottom of my fraction here? Which is 23. 25 minus 2. This is why we multiply by the conjugate, because my square roots all cancel off. So then all that's left for me to do is simplify. Distributive property. 10 plus 2 square roots of 2. Right, because 2 times the square root of 2 is 2 of them. And then 25 minus 2 is 23. This is considered simplified. This and that are the exact same thing. This is just considered simplified because there's no square root in the denominator of the fraction. No. If both of these numbers and the bottom number were all reducible by the same number, you could reduce it down. So like if this was 22, you could make this 5 plus 1 square root of 2 over 11, and they're not reducible. What's the problem? Perfect. That was just the other type of problem I was gonna go over. So this is also learning target 4 and simplifying radicals. Let's say I have the 4th root 2 over. Sorry, I got to do a little math here. over 125. Okay, I can't have a fraction in my radical, and I can't have a radical on the bottom of a fraction and it be considered simplified. So what I am going to start by doing is I'm going to split this up so I have a radical on top and a radical on the bottom. Okay, so then when I have this, I need to look at the bottom here, and I need to make the bottom a perfect what? I need to make it a perfect fourth power. So the thing I'm going to do is I'm going to start looking at my fourth powers. I'm going to start looking at my fourth powers, and I'm going to start asking myself, can I multiply 125 up to that perfect fourth power? Is there anything I can multiply 125 by? That's a nice neat whole number to become 1. What, 16? 81? These are all smaller, so those aren't going to work. What about 256? No. What about 625? That's a possibility, right? So I'm going to take 625 and I'm going to divide it by 125 and I get 5. So can I multiply 125 up to become a perfect fourth power? Yes. I can multiply it up to become 625. Divide to become 625. Since I have to multiply that by 5, I have to do the top and the bottom, because then this becomes 1. This is now the number 1, and I'm not changing value. So I multiply straight across, and I get the 4th root of 10 over the 4th root of 625. And this is convenient because I cannot have a radical in my bottom, but what do we know about the 4th root of 625? It's 5. Fourth power, 625. Root is 5. So this is the 4th root of 10 divided by 5. And then that's my final answer. Okay. Both of these learning targets were not very, or this is the same learning target, just different versions of it. Both of these were less than great that we need to keep working on. So I'm just giving you constant reminders. Yeah. So on a problem like this, you have to make the bottom a perfect fourth power here in this situation. Now this one, which was a homework problem, you need to make this a perfect square because we're square rooting. All right, that's all I wanted to cover for right now. Otherwise, we're going to start 6-4. We're not going to get all the way through 6-4, but we'll get a good chunk of the way through. My favorite section of this chapter, not even close. I just said it. Calling me nobody. You guys are hilarious. No, I'll be able to catch you up during work time. It'll take you 5 minutes. 2 learning targets. Okay. The first is that you're going to solve equations containing radical and rational exponents. Today, we're only focusing on radical. So today, our learning target is I can solve equations that involve radicals. Next class, we'll deal with ones that have rational exponents. Okay. And then additionally, we're going to determine whether a solution is considered an extraneous solution, which we. Let's just talk about the learning target 6, which is solving radical equations. Okay, radical equations, obviously equations that involve a radical symbol. Okay, your first goal is in general to isolate the radical. I believe that these problems theoretically will make a lot of sense to you based on work that we've already done and will not be overly difficult if you can start by isolating the radical. So if you look at this problem here, I have this little 2 outside the radical. Remember, the radical is like the rooting symbol. The radical is the rooting symbol. So it's like this thing here and then this thing here. That's a radical, the rooting symbol. Okay. So when I have a 2 right next to it, what math operation is that? multiplication. It's important to note I cannot distribute across the radical symbol. So I have to undo a multiplication of 2 by dividing by 2. I divide by 2 and I get the square root of x plus 1 is equal to 2. In previous problems that we've done in this class, this semester, we have said, how do you undo fourth power? We've had problems like that. How would I undo the fourth power? Fourth root. We're just going backwards from that. How do I undo square root? Second power, which is squaring. So you just have to understand that relationship. Earlier, we talked about fourth power is undone by fourth root. Well, that means that fourth root is going to be undone by fourth power. They work back and forth from each other, which in my mind makes total sense. And also in your mind now it makes total sense because you guys are all experts with this. So we know that square rooting and squaring are inverse operations of each other, like addition and subtraction, multiplication and division. They undo over. And then is equal to 4. 2 squared is 4. And then all I have to do is solve. Okay. I'm just going to go ahead and get you in the habit of you checking your work. Normally, I'm not one to say that, hey, you have to check all of your work all the time. These ones you're going to. So I should be able to plug 3 into this side of the equation and get, when I hit enter, I should get 4. So I'm going to take my calculator, I'm going to clear out whatever's there, I'm going to hit 2. And then remember to get the square root button right there, you have to hit the x squared, you have to hit second x squared. And then what number is replacing x? 3. 3 plus 1. 2 times the square root of 3 plus 1, which is 2 times the square root of 4. Or square root of 4 is 2. 2 times 2 is 4. So I checked my work and it worked out. So this is my answer. I'm just getting you in the habit for that because there will be problems where you're going to check your answer and it's actually not going to work. What about 2? How do I get the radical by itself here? Plus 1. Notice that this minus 9 is inside the radical. So I can't do anything to that until I undo the radical symbol. This minus 1 is outside of the symbol, so I can undo that right away. All right, and so then now I'm in the position where I need to undo this third root. And what's going to undo the third root? Third power, or cubing, same thing. So I got to cube each side here. Those are inverse operations of each other. Cube rooting and cubing undo each other. And now I get 2x minus 9 is equal to 27. Fourth power, yep. If it was an 8, you would do 8th power. If it was a 1 million here, you would do 1 millionth power. All right. So then I just solve from here. Uh, 27 plus 9 is 36. Then we divide by 2. So I know that x is 18. I'm going to check my work. Anybody remember where I get the third root from? Hit the math button. And it is amazing that our calculators have a button dedicated for math. Because if you think about it, they're all dedicated to math. Yeah, thank you. Appreciate it. All right, so 2 times 18 minus 9. And then I need that -9 to be the last thing under the rooting symbol. So I have to close the parentheses here. Because this 9 is the last thing under the square root or the cube root symbol. So I need to close my parentheses there and then hit an additional -1. And it's 2. So if you have the 84 or the 84 plus calculators, once you hit your -9, to get out of the root symbol, you have to hit the right arrow and it will take you out of it. And then okay, so this is my answer. All right. Is there anything I can elaborate upon? Okay. 5, 7 minutes or so, 5 to 7 minutes, is you're going to find somebody you trust mathematically. And one person's going to do A, and then one person's going to do B, and then you're going to cheat off each other. Okay. That means you get to copy their work. So one person's doing A, one person's B, and then you're going to share your answers. Okay. I'm going to do my work behind the scenes, and then I will share out when you are done here in a second.
I'm proud of you.
Like on this one here. Second group. I'm gonna freeze the screen so you can see. Keep working or still when you're working or partner or whoever. I was asked to why? Well, here's the thing. I just want to be able to separate myself from the coach. I just want to we're going to be rewriting. I can do that one. I know that the square root of this inside number is going to be 2, so this inside number has to be 4, which it has to be negative 20. Yeah, opposite.
That's what I did. I just did what we're supposed to do.
All right. Any questions about those? Walking around, it looked good. One question that I had that I thought was a good question is, what root is this if there's no 2? And a lot of times when there's no number written there, it's 1, or sometimes when there's no number written there, it's 0. This is the weird situation when there's no number written there, it's a 2. Okay. So no number written there on my radical implies that it's the second root or square root. All right. These are good questions, but the problems that we're going to do are going to be more complicated than this. Okay. So we're going to go right to 4. So now what we're going to do is we're going to solve these problems, and the same concepts that we talked about in the previous examples are going to hold true. We're just going to get these things called extraneous solutions. And essentially what those means are, we're going to get answers. We're going to get more than one answer. But one of those answers is going to be like an imposter. It's going to be like a fake answer. Okay? So it's going to be, we're going to get 2 answers. One's going to be an answer, and one is probably not going to be an answer. And I will do my best to explain why also when we get there. Okay, so same thing. We got to try to get the radical symbol by itself. Is the radical symbol by itself? The radical symbol is by itself. So yes, I can square it to undo this. So I'm going to square each side. Notice how each side here is in parentheses. That is relevant. Now, here, x plus 1 squared means x plus 1 times x plus 1. Now, I know most of you are going to want to go get Pascal's triangle out and expand that binomial that way. But for those who are not interested in it, it is a-okay to use your box method of multiplication and just go x plus 1 times x plus 1. Okay, so we're going to go x times x, 1 times x, x times 1, 1 times 1, and then my diagonals are like terms, and they combine. So the left side of the equal sign is x squared plus 1x, and 1x is 2x's, plus 1 is equal to 7x plus 15. You know how I can tell we're really hitting our stride is that I can pause and you guys know when I want you to answer. We're just killing it. All right. Now, there is probably a little bit of questioning about how exactly you solve something like this. Okay, so this here is the big giveaway. I have a degree higher than 1. If the degree is 1, so let's say there was no x squared, this would be an example of a degree of 1, you just get the x by itself. Here I have a higher degree. This means we need to set equal to what number? And what do we do once we set it equal to 0? Factor. And I don't know about you all, it would be great if I had like a piece of paper with like, I don't know, a bunch of great information that you just follow, like some sort of information to figure out how to factor. Oh my gosh, what about this in here? Look at that. We do have an information about that, but let's set this equal to 0 first. When you set it equal to 0, move things to the side of your x squared or your x cubed, or whatever you get. So I'm going to do both minusing 7x and 15 at the same time for the sake of time. And I'm going to get x squared minus 5x minus 14. And as some genius pointed out, they said we have this fantastic flow chart that will diagram to you exactly how to factor this if you don't remember. Okay, first thing we want to do is take out the greatest common factor. So is there any greatest common factor here? 1, so no greatest common factor. How many terms do I have? 3. When there's 3 terms, I find my a value, b value, c value. So a value here is 1, b value here is -5, c value here is -14. Knowing all of that, I have to ask the question, does my a value equal 1? Yes, it does. Therefore, my method of factoring is the multiply to c value, add to b value method. Right here. 1 minus 15 is -14. Oh, sorry. This 1 minus 15, because I minus 15 over here and here. Okay. So now we're looking for combinations of numbers that multiply to -14 and add to -5. It's -7 and +2. Okay, I did have some good questions earlier in first block about how can we come up with these combinations so fast? Well, I can tell you, me personally, obviously, I've done this a million times. My math facts, decent. Hypothetically, if yours are not so decent, you have to start listing combinations. You're going to say, how can I multiply to 14? Don't try to add to -5, because there's an infinite amount of combinations that would give me this. But there's only a limited amount of whole number combinations that will get me to 14. So the first thing I'm going to do is 1 and 14. And I'm going to say, what 2 numbers can 1 and 14 give me? It can get me to 15, and it can get me to 13. So either of those, but neither of those are what I'm looking for. So then I'm going to take 14, I'm going to divide it by 2, and I get 7. These combinations can get me to 5. These combinations can get me to 9. I know that since it can get me to 5, I just have to figure out what combination is going to actually get me to -5, which is this combination. And then you would just keep going. Divide by 3, divide by 4, divide by 5. Eventually, you'll repeat yourself. So since these are my combination, these are my factors in the multiply to c, add to b combination. So we're going to get x minus 7, x plus 2. These are each a factor, right? The -7 and +2. And then once I have my factors, what do? Set them equal to 0. And then solving at this point, hopefully, is fairly easy. Do not box either of these in, because one of these is actually not a solution. We're going to find out here in a second. Okay, so this weird thing happens when you square an equation. When you square an equation, particularly the one with a variable, if you have something that's negative and you square it, you're going negative times a negative, you get a positive. And if you square something that's positive, you get a positive also. So no matter what, when we square these things, we end up with like this positive x squared here. And it just causes some tricky things to happen. So what I'm going to do is I'm going to look at our original equation, and I'm going to look at the graphs of the original equation to figure out. I'm looking for when the line x plus 1 is equal to the square root of 7x plus 15. So what I'm going to do is I'm actually going to graph each of these. So I'm going to hit graph by hitting y equals x plus 1 in the first one, the left side of the equal sign. And then I'm going to do the square root of 7x plus 15 on the right side. Y equals. square root, you hit the yellow second button, and then you hit x squared. It's diagonal. And so if I'm looking for when this line crosses this radical function, which we talked about radical functions before, when we look at the graph, we're going to look for where they what? Where they intersect. They intersect here, which is roughly at what number? 7. But do they intersect here at -2? They actually don't. So which one of these problem answers is actually our answer? The 7. That is going to make this answer extraneous. So this answer is kind of an imposter. We did all this math and it comes out and it works, but it just actually isn't an answer. You're going to communicate to me an answer that is extraneous by not boxing it in or circling it, and by putting a little ext next to it for extraneous or extra. Okay, so you can check it with the graphing calculator like that. You can also check these by hand. Okay, so you can check this by hand by plugging in x is 7 in the first one. So we have 7 plus 1 is equal to the square root of 7 times 7 plus 15. 7 plus 1 is 8. And then this here, I'm probably just going to type in my calculator. So I'm going to do my square root symbol, second x squared. That'll get you your square root symbol. And then do that 7 times 7 plus 15 underneath the radical symbol. And I get 8. So both sides equal out to the same number. So that means I know 7 is an answer. And you do need to check both answers because it is a possibility for both answers to be true answers. Not sure about both extraneous. I'd have to do some more thinking about that. Okay, so now I can do the exact same thing for -2. -2 plus 1 is equal to the square root of 7 times -2 plus 15. -2 plus 1 is -1. And this side here, again, I can just type into the calculator. And you do not need a graphing calculator to type this. A regular calculator, like I don't know which ones are called. Yeah, the littler ones will work too. The square root of 7 times -2 plus 15 is positive. So in this one here, I don't even get the same number. I get -1 is equal to +1. And that is also why it's extraneous. So you can check this by hand. Well, you have to be able to tell me which one's extraneous. Because this is like last chapter, we had problems worth 5 points. Like one for telling me how many solutions I was going to have in solving. This is another example of that. You're going to have 4 points for getting me my answers. And then you're going to have 1 additional point assessing learning target. I think it's 6, 7, telling me which answer is solution or is extraneous or not. Then you get your point. Yeah, then you'll get your point. But do you know how to get that is the big thing. And down here is how you're getting an extraneous answer, or by looking at the graph. Okay. We have enough information to try example B. Yes, okay, go for it. Go. The fact that this is not true, okay, tells you something about this answer. That it's an imposter. It's an extraneous answer. This I know, you plug it in and check it, and if it's actually your answer, then it'll come out true. If you plug 9 into this and the 1 was, it should come out true. Wait, just kidding. You're gonna type in the left side into the first. No. You'll just type the equation into y1, the left side of the equation into y1, and the right side of the equation into y2. You don't have to show this work down here. If you can understand how to graph and identify your solution. Yeah, that wall. Oh, yeah, oh my God. Why do I only do that? I on the board. I on the board. My answer is why I was trying to work. same number on both sides. I did get the same number here when I plugged in 1, so that's extraneous. When I plugged in 9, though, I got the same number on both sides. Or you can plug this into the y1 of your graphing. You can plug this into the y2 of your graphing. Graph both at the same time, and you'll see that they can cross at 9, but there's no chance of crossing at 1. This is extraneous.
We don't know that exactly, so we don't have to do it. We don't know exactly where we stop, so we have to do it.
I see.
All right. There is a 10, 11, and 12 on the 6-4 homework. That's what we'll cover next time. But for today's class, you only have to do 1 through 9. Okay, 7, 8, and 9 got cut off in the printing. So make sure that this is exactly what you have if it got cut off. Yep. Okay. Getting it.